Okay, so this is problem 1630. Write detailed mechanisms for each of following reactions. That part A, we have this cyclic ether with double bond. We react that with sulfuric acid with this benzyl alcohol. To produce this product here. And so we'll begin with our starting material. And the electrons from this oxygen can move up, and we can kick off these electrons from this double bond and use them to pick up a proton from sulfuric acid. Trying to adjust the focus here, make things a little easier to see. Second. All right, so I think that's a little better. Anyway, once we pick up the proton from the sulfuric acid, then we essentially have this sort of, we have a cyclic oxygen, this carbon-oxygen double bond. Not exactly sure what that would be called, but anyway, it reacts with our benzyl alcohol. Push those electrons back onto that oxygen. Then we need to deprotonate, and we can do that using another molecule of our benzyl alcohol. So once we deprotonate, then we arrive at our target. So there's the mechanism for this reaction that we again use these oxygen electrons to force that double bond to pick up a proton from the sulfuric acid. Then this ion can serve as a target for, it can accept the electrons from this oxygen from this alcohol. Then we deprotonate this ether to form our final product. So we'll come on down the paper and do part B. We have a cyclic ketone with this alcohol group. We react this with methanol and catalytic sulfuric acid. And we want to form this molecule. It's an acetal, and so the first step will be to protonate this carbonyl and we'll use a protonated methanol as our proton source. Once we have the protonated carbonyl, then we can get the electrons from this alcohol oxygen to attack that carbonyl carbon. Push the electrons up to this oxygen. And it will form another six-membered ring. 1, 2, 3, 4, 5, 6. Yep. And so that forms this part of our target. Now we need to get the replace this hemiacetal with the acetal, and so we protonate our hydroxyl group again And we'll use another protonated methanol as our proton source. Go ahead and rotate this molecule so that it matches our final product. We have this protonated alcohol. Once we have that protonated alcohol, then electrons from this ether oxygen can come down, kick off that protonated alcohol as water, makes a good leaving group. So once we have this positively charged species with this carbon-oxygen double bond, then we can get a methanol to attack that carbon, push the electrons back up onto that positively charged oxygen, and we'll have this protonated ether as part of our acetal. So then we just use another molecule of methanol to deprotonate. When we deprotonate that oxygen, and we arrive at our target. So again, we start by protonating the carbonyl. Then we close the six-membered ring, and then we protonate this hydroxyl group to form water as a good leaving group. Then we kick off that water. Methanol can come and can attack this ion to form this protonated acetal. Then we can deprotonate the acetal and form our final product. So we'll move on to part C. This five-membered cyclic amine. Attached to this six-membered ring with this double bond. So this is an enamine. We react our enamine with water and catalytic sulfuric acid. We form a cyclic ketone. Plus this 5-membered cyclic amine. So this is a reverse of the enamine formation mechanism. And so we began by using the electrons from this nitrogen to come down, forming a double bond with this carbon, and we can kick off the electrons from this other double bond to pick up a proton Then once we have this ion, the next step is to attack this carbon with another molecule of water. Pushing the electrons back up to that positively charged nitrogen. Then we can deprotonate Once we deprotonate, we can use the electrons on that nitrogen to pick up another proton. Then we can use the electrons from this oxygen, come down, and kick off our protonated amine. We have a protonated ketone now. plus our this part of our target, and then a molecule of water forgot my color coding. Molecule of water can attack and deprotonate the protonated ketone, forming our cyclic ketone, which is the other target. And so we have both of our target molecules, and that's the mechanism for part C. So part D we have this acetal. We react it with water and catalytic sulfuric acid. We produce benzaldehyde. Plus this diol. So the first step is to protonate one of these oxygens. It doesn't really matter which one. Once we protonate that oxygen, then we can borrow some electrons from the other oxygen. They'll come over. We can kick off that protonated oxygen. And open up that ring. Once we get to this point, a molecule of water can come along. Attack this carbon. Push those electrons back onto that positively charged oxygen. Then we need to deprotonate. Once we deprotonate, then we can protonate this oxygen here. Once we have this protonated oxygen, we can borrow a set of electrons from this other hydroxyl, kick off our protonated ether as a leaving group, form a protonated aldehyde plus this molecule, which if we just fold that a little, we show that that is the same as this molecule, and so this is one of our target products. Then all we need to do is to deprotonate our protonated aldehyde, and we arrive at the other of our target molecules. So that's the mechanism for part D, that we have to go through a series of protonation and deprotonation steps to kick off our acetal and form our carbonyl.